Today we're going to begin solving equations using addition, subtraction, multiplication, and division. And in order to do that, we need to know about equivalent equations. Equivalent equations are two equations that are equivalent because they have the same solution. So here's an example. So I have 3x plus 2 equals 11. This is my equation. The solution for this equation is x equals 3. And I can test that out and make sure this is my solution by taking this 3 and plugging it back in for x. 3 times 3 would be 9, plus 2 would be 11. So this is our solution. Here's another equation, 3x equals 9. Well, x is 3 is our solution again. I can check it by plugging it back in. 3 times 3 does in fact give us 9. Since both these equations have the same solution, they are equivalent equations. When solving equations, we have quite a few very important properties. We're going to start with the addition property of equality. This property says that if you're adding the same number to each side of your equation, it's going to produce an equivalent equation. Basically, you can add anything to your equation as long as you're adding it to both sides and keeping the equation equal. So if I'm starting with x minus 5 equals negative 1, I want to isolate my variable. I want to figure out what x is, and therefore I need to get x by itself. Currently, I have x minus 5. To get rid of that, I'm going to use my inverse operation. The opposite of subtracting is adding, and I'm going to add 5. But in order to keep both sides of the equation equal, I need to make sure I add 5 to both sides. So over here, if I'm subtracting 5 and adding 5, they're actually going to cancel out. And I'm going to just be left with x. On this side, negative 1 plus 5 leaves us with 4. We can always check our solution by plugging it back in. 4 minus 5 would give us negative 1, so x equals 4 is our solution. The subtraction property of equality is very similar to the addition property. It's just stating that if you subtract the same number and you do it from both sides of the equation, you maintain equivalent equations. So you can't just subtract something from one side. You have to do it to both sides in order to solve your equation. So if I'm solving here for w, I currently have w plus 13.2. So I need w by itself. I have to get rid of the plus 13.2. The inverse operation to addition is subtraction. So I'm going to subtract 13.2 from each side. And I get w on this side after the plus and minus 13.2 cancel out. And on this side I'm left with negative 2 8/10. Also works for multiplication. Our multiplication property of equality says you can multiply an equation by a number as long as you multiply both sides of the equation by that number. So here, I started off with v divided by 3 equals negative 6. So the opposite of dividing by 3 is multiplying by 3, and I'll have to do that so that the multiplying and dividing by 3 cancel out, and I'm getting v by itself. So in this case, v equals negative 18. And last but not least, dividing. As long as I divide both sides of my equation by the same number, I will have an equivalent equation. So I started with 18 equals negative 4y. I'm dividing both sides by negative 4. So here, negative 4 and negative 4 will cancel out. And 18 divided by negative 4 leaves me with negative 4.5 for the value of y. So here we have a company that has a profit of $750 this week. That's $900 more than their profit, capital P, from last week. So the profit from last week is going to be represented by this capital P. And they want to know which equation can we use to find that profit. So we know that last week they made this week they made $750, and it was $900 more than the profit last week. So $900 more than P. Well, a key is these words more than. More than means I'm adding. So I'm going to look for something where I'm adding. So I'm down to these two choices here, B and D. So 900 is what I should be adding. 900 more than P. So that leaves me with option B. So I'm going to use this equation to actually try to find the value of P. What was their profit previous to the week where they made $750? So 750 equals P plus 900. Now I'm trying to figure out what this P is. So I need this P by itself. So I have to get rid of the plus 900. So the opposite of adding is subtracting, and I would want to subtract the exact same amount so they cancel out. But I need to also subtract that amount from this side. So 750 minus 900, their profit was negative $150, or they were at a loss of $150 the week previous. When we're solving equations, it makes sense to sometimes use reciprocals. Remember, the reciprocal is the flip of a fraction, or when you reverse the numerator and the denominator. And let's see why that would be useful. So if I'm trying to solve an equation like negative 4/5 x equals negative 8. So I'm multiplying by negative 4/5. You would initially think, okay, well, the opposite of multiplying is dividing. So I'll divide both sides by negative 4/5. So now this cancels out, and I'm left with x equals negative 8 divided by negative 4/5. Well, ultimately, to solve a division of fractions problem like this, I'm going to take that negative 8 and multiply by the reciprocal here. So I could go straight to this part where I'm just multiplying by the reciprocal and solve this to get x equals 10. So it's a bit of a shortcut. Let's see how that works with this problem. So it's 2/3 times x equals negative 14. Well, instead of dividing by 2/3, I'm going to multiply both sides by the reciprocal. So I'm going to multiply by 3/2 and multiply by 3/2. So here the fractions will cancel each other out, and I'm left with x. And this side, I'm going to actually multiply. I'm going to add a 1 denominator to my negative 14. And I see there's some cross reducing I could do here. So I can divide 2 by 2 and get 1. And negative 14 divided by 2 is negative 7. So on top I get 3 times negative 7 is negative 21 over 1. So negative 21 is my value for x. Let's try another one. So I have negative 3/8 times h equals negative 9. Well, rather than dividing by negative 3/8, I am going to multiply by the reciprocal. So its reciprocal would be negative 8/3. The numerator and the denominator flip. It's still negative though. So these guys will cancel out, and over here I'm going to multiply by negative 8/3. I'll add a 1 to that 9, this negative 9, so it can participate in the problem there. And I see some cross reducing I can do. I can divide by 3 here. And I get h equals 24 over 1, or just h equals 24. All right, let's look at one more problem together. The record low temperature in Hawaii is negative 0.15 times the record low temperature in Alaska. The record low temperature in Hawaii is 12 degrees Fahrenheit. What's the record low temperature in Alaska? So what we're trying to find is this low temperature in Alaska. So I'm going to call that T. T is going to stand for my low temp in Alaska. And I know that negative 0.15 times this low temp in Alaska, so negative 0.15 times T, is going to equal the low temperature in Hawaii, which was 12 degrees Fahrenheit. So I've made an equation that I can now use to solve for T. So I'm going to divide both sides by negative 0.15. So it cancels out here, and I'm left with T. I know T is going to be negative because a positive divided by a negative gives me a negative. But I'm going to have to do a little work over here to find the exact value of T. So Whenever I have a decimal out here, I'm going to move my decimal all the way over to the division bar. I'll do the same here. Since I don't have any extra numbers, I'm going to add in some zeros. So this is really, how many times does 15 go into 1,200? Well, 15 doesn't go into 1 or 12, but it will go into 128 times exactly. And I'll bring down my 0, and 15 goes into 0 times. So I get negative 80, and this would be degrees Fahrenheit. So the record low temperature in Alaska is negative 80 degrees Fahrenheit.